Hello, welcome back to my channel Max Logic Solution. Today we're discussing about some of the important questions related to term 2. Okay, term 2, the arithmetic progression. Okay, then first of all, we have to discuss some of the formulas included in our arithmetic progression. Okay. These are the most important formulas we have to see in our arithmetic progressions chapter. Okay, first one is an is equal to a plus n minus 1 into d. This a is the first term and d is the common difference. How we have to find the common difference from our terms? So that is d is equal to an plus 1 minus an. And the last term, the nth term an is equal to sn minus 1. This is also a most of the important formula from this set, because some of the problems can be related to solve using this formula. Okay. So Sn is equal to the nth sum, the sum of n numbers. Sn is equal to n by 2 to a plus n minus 1 into d. Then clearly this a is the first term and d is the common difference. So we move to our some of the problems. Your first question is, which of the following can be the nth term of the arithmetic progression? They are given three options. First option is 4n plus 3. Second option is 3n square plus 5. And the third option is n cube plus 1. Give the reason also. So, which one is the nth term of our arithmetic progression? Here is given that three options. And we know the nth term in the form of an is equal to a plus n minus 1 into d. Okay. Then this is the general form of the nth term of our arithmetic progression. So, we have to say that this one 4n plus 1, first we consider this 4n plus 1. 4n plus 1 can be the nth term of arithmetic progression is in the form of linear relation in n, which means that a linear relation become then only one term is the variable. So here n can be considered as a variable and there is no degree, there is no higher, the higher degree of this n is 1. So we can consider 4n plus 3. 4n plus 3 is the nth term of our arithmetic progression. In these 2 and 3 cases, here is it is a quadratic form and is also the degree become 3. Then these two of them are wrong, because the arithmetic progression's nth term is also in the form of linear form. So that means 4n plus 3 is our answer. Clear? So your next question, the second one is 144. 144 is the term of the arithmetic progression. They given the arithmetic progression is 3, 7, 11, etc. Then they ask that the justify your answer also. Okay. Then here is a first term a is equal to 3. A is equal to 3. This is an odd number. It is an odd number. Then we have to take the second one, a2 is equal to 7, and then we have to find the common difference, a2 minus a, that is equal to 7 minus 3, that is equal to 4. Then if we add an odd number with an even number, that become an odd number. Okay, if we add an odd number with the even number, that will be an odd number. But in this case, they are asking about 144. 144 is an even number. So we have to say that this is not the term of our arithmetic progression. This is not a term of our arithmetic progression, because 144 is an even number. If we add an odd number with an even number, we get the odd number. But in this case 144 is an even number. So this is not the term of this arithmetic progression. Clear? The third problem is, the first term of an arithmetic progression is p and the common difference is q. Find the 10th term. Then given that here is the first term a is equal to p and the common difference d is equal to q. Then we know the difference. We know the nth term an is equal to a plus n minus 1 into d. Okay, a plus n minus 1 into, here we can put the value p plus n minus 1 into d become q. Okay, then we have to find the 10th term, so we can remove this n with 10. A 10 is equal to p plus 10 minus 1 into d, 10 minus 1 into q, which is equal to p plus 9 Q. Okay, this is our 10th term of the arithmetic progression. Then you must study this formula. An is equal to A plus n minus 1 into D. We are using this nth term of an arithmetic progression formula using to find this problem. Clear? Then we move to our next problem. This is our fourth problem. If the nth term of an arithmetic progression is 3 plus n by 4. This is the general form of the arithmetic progression. So we have to write like this. An is equal to 3 plus n divided by 4. Okay, the nth term of an arithmetic progression is this one. Then they are asking about to find the 8th term. So you put the value of 8th term. N is equal to 8. N is equal to 8. You have to find A8. You have to find that. So you just put the value instead of the n. That is equal to 3 plus 8 divided by 4. 3 plus 8 divided by 4 become 11 divided by 4. So our 8th term become 11 divided by 4. Clear? This is a very simple problem, but these are asking in your questions like this of the form. So concentrating on our nth term and put the value in the place of n. Okay. So your fifth problem is for what value of p? For what value of p are 2p plus 1, 13 and 5p minus 3. These three numbers are the consecutive terms of AP. Consecutive terms means that these are lying in like this 1, 2, 3. These are known as a consecutive numbers. Then after 1 we know that this one is 2. After 2 we know that 3. The same way then this one is known as 2p plus 1 after the number is 13 and after the number is 5p minus 3. This is known as a consecutive number. These are like beside the each one is together. Okay, so we using these three terms. Then we have to take that this one is the first term, this one is the second term, and this one is the third term. So we know that second term minus first term is equal to our common difference D. Second term minus first term is equal to our common difference D. So here is the second term is 13 minus our first term. This one is the first term 2p plus 1 which is equal to D. Okay. Then using this equation we have to find the value of the number, the letter P. The same way we have to write that D is also like we have D is equal to 5p minus 3 minus 13 is also the common difference. We get the same common difference. Okay. Then 5p minus 3 minus 13. Then this become 5p minus 16. 5p minus 16. Then this one is equation number 2 and this one is equation number 1. Okay. From this equation number 1 we have to solve this one is also. Then equation number 1 can be solved like this. 13 is here. After that you open the bracket minus 2p minus 1 which is equal to D. Minus 13 minus 2p minus 1. Minus 13 minus 1. What is the answer? 12. 12 minus 2p which is equal to D. So this one is the third equation. Then we use this these two equations, okay, to solve our common difference. We have to solve these two common difference and we get the value of D. Okay. So using our formula equation number 3 and equation number 2 also here that. Next we write this equation number 12 minus 2p which is equal to 5p minus 16. Then we compare these two of them. Here is a 12 and here is a minus 16. Minus 16 can be taken in the left side. We get 12 plus 16 is equal to 5p and negative 2p can be taken in this side. That is equal to 2p plus 2p. So which is equal to 28 which is equal to 7p and implies that p is equal to 28 divided by 7 which is equal to 4. So the value of p become 4. P is equal to 4. This is our answer. Okay. Then we just concentrate on in this equation they given a clue that 3 consecutive numbers. This is the clue from this question. So you write these 3 of them are like this in this way, and then the second term minus first term is equal to the third term minus the second term. That is the same value for the common difference, because they are lying in a arithmetic progression. They given that they are in a arithmetic progression, which means that the common difference of these 3 of them are equal. Then using this step you have to solve the formula, and you have to get the value of P also. Okay, then here is only 5 questions we discuss in from the question papers, and it's a very important questions. So you have more, you want any more questions related to the arithmetic progression, please comment on my comment button, and please subscribe my channel. Thank you.